Okay. Testing. Yeah, it looks like it's working. So we're missing one student up here, but I guess we can start. Um, so, like I said, I just got off the airport here at the local Pine Belt. Lots of times I go to Gulfport, but this time there was really cheap flight out of Hattiesburg. So what I'd like to do is continue on our discussion, but next week there's going to be a test on the schedule, right? Now, you need to take it early. So you're just not going to be here at all that day? Okay. And then, Elida, you need to take it early too, right, or something? Because you're going to go to the presentation. Right. Okay. It's a presentation that's being given by Dr. Puckett, right? Yeah. 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 No, nobody on the coast. Does anybody on the coast have a conflict with that? You don't have a conflict next Tuesday. Okay. Well, I do want to come down there again. It's been a little while since I did. So I could come down, on the test day. And what I was thinking for the test is scaling back the test a bit, so it's kind of more like a something between a quiz and a test. Just and then still having about an hour of discussion after. So basically you'd get a little bit over an hour to take the test. But I still think it'd be better for the coast if I came down during a full lecture period. What do y'all think? So I can either come down next week or the week after. I was leaning towards the week after. Does that sound good? Okay, that sounds good. All right, so the order of the day today is that we'll have our discussion and we'll talk about basically what's called JSON, and we'll make it geographic, so we can add points, lines, and polygons to our map as a layer. Then hopefully we can end about a half hour early, and I can just spend some time talking about what the test's going to be. I usually like to make a review sheet. The write-ups for this course have been pretty succinct, so there's not a whole lot of reading, and that's what I mean, because there's not a book. So the things I've written up are pretty good study guides already, but I'll condense them down. I'd planned to have that up, but I don't. So I'll go over the kind of format of the test, answer any questions, and I don't picture that lasting over half an hour since we don't have a study sheet to go up. And I'll make the study sheet tomorrow in the first 3 or 4 hours. And post it to Blackboard. All right. So I did make I did make a reading for this week. So unlike what I've done for the last few weeks, I made a reading. I posted it on Blackboard. Right now, it's the only thing posted on Blackboard. So we've kind of been going this direction all along, but I just wanted to make sure that you understand that we've been working on our web maps, and we haven't really displayed a lot of anything yet, but we have displayed some traditional imagery-based map services, or those fall into two categories: tiled or dynamically drawn. We introduced that concept a little bit in the first week, and that used to be, up until a few years ago, that was 99% of all web maps. If they did place an object, it was just a single thing, like a marker, you're here, or something. But now, as an alternative to having the server side do all the work actually drawing our data, we can have the client do some of that work. Instead of the client getting an image, the client gets the actual data to play with. And so that's what I mean by an alternative to this approach is to send some text. So the web actually, at least for now, it's maybe changing. You know, the web always continues to evolve, but at least for now, the web actually communicates through sending pictures, images, and text around, and pushes those around through the pipes. And so if we want to send data, that data actually has to come over as a text file. And so that's the alternative approach, is to send some text to the web browser. This could be just in a static file, like an image, except for it could be actual data, and we'll show what this looks like in a little while. Or there could be a server, which just is a fancy word for saying there could be a program out there waiting for requests. And you might say, send me all the fires that happened in New Mexico, and it would send you back the points, probably points for fires, maybe polygons, depending on how they stored it in the database. But it could send back those data as points right to the client. So why would you do this? Well, this approach can improve the speed and interactivity of your web map when used wisely. So basically, you can confuse your web map. You can have so much data that a web map really is not the appropriate, or a web browser really is not the appropriate program to deal with such a large amount of data. So if I had millions of points, it'd be more appropriate for a very fast computer to symbolize those, turn it into an image, and send it to the client as an image, rather than sending them all the points and saying, you take care of symbolizing them in the JavaScript code. When I say the client takes care of symbolizing it, I mean that the JavaScript code takes care of symbolizing. So, maybe, but maybe not. You might be asking, how does a client like a web browser know how to draw GIS data? This basically comes down to there being standards for the data being transferred, and there being these APIs, what we talked about, Leaflet and ArcGIS JavaScript API, out there that can take these standard data formats and deal with them. We've actually already done a little bit of that when we just uploaded that CSV file to ArcGIS Online and CartoDB. Exactly. So a CSV can be thought of. It's not really as strict of a standard as other formats. That's why you had to tell it, which field represented the latitude, which field represented the longitude, things like that. But it is a format, and it can be ingested by most of these JavaScript APIs, which, by the way, CartoDB is using Leaflet, and ArcGIS JavaScript API is being used by ESRI. All right, so yes. Sorry, I hit that once. Did it used to did it show up for a little while and stop? Okay, I hit it right at the beginning of class, so maybe the button. This document is on Blackboard, so you can download it. So one of the most common ways to share geographic data as a text file is called GeoJSON. And that's what we're going to practice a lot today. An older format that is more related to HTML than it is to JavaScript is called KML, which stands for Keyhole Markup Language. I do believe we talked about that a bit. So KML looks a lot like HTML, where it has the brackets, it's still used widely, but GeoJSON is much more common because it's already, you'll see in a second, it already is in JavaScript. In fact, the acronym JSON, J-S-O-N, stands for JavaScript Object Notation. So what's really cool is that we don't have to handle in our JavaScript code placing these, doing all the math that's necessary to convert these XY coordinates that are in GeoJSON files into screen coordinates. All that is done using the code that's written by these people that have written ArcGIS JavaScript API and Leaflet. And it handles figuring out where to put those on the map. So what we're left with is one, figuring out the programming interface, what exactly we need to type, and then two, the symbology. So this is still a little bit more on why we would do this. So speed and interactivity are the two basic things, the two basic reasons why we would use vector data instead of just requesting pictures on the internet. So you can with a vector that's on the client, you can update symbology without making another request to the server. So if there's something that your user wants to do, they want to change a color. If you program that in, that doesn't need to be a request back to the server. That's simply a few lines of JavaScript code. You say, okay, well, take all these and change the color of all those, and we're done. We don't have to make a request. And so that allows your web page to be more responsive, because it doesn't have to reload the image in the background in order for the map to update. Interactivity is related to that. See, here was the example. Let's suppose I have a web map of the United States with all the NFL football teams displayed on it. Okay. Oh yeah. So ignore this part right here, because this was from last semester. I tried to make most of it change, but we didn't have a previous lesson on that. That's going to be a coming lesson. Okay. All right. Now, as I mentioned, not every use case is appropriate for drawing vectors on the client. So, like I said, if you're displaying lots of features at the same time, it may or may not be appropriate. It depends on how you define lots. Hundreds of features is usually okay, but if you have hundreds of polygons, and all those polygons are very complex, what it boils down to is actually the number of vertices. Because every vertex comes over as two numbers in text. So if you have one polygon that has 1,000,000 vertices, it's the same expense as having one 1,000,000 points that are on the screen. In other words, it's roughly the same amount of data that's coming over. Many of the server programs that actually pass data in these formats, in these text formats, actually will limit the amount of data that they'll pass. And that's one of the parameters you can set. You can say, okay, I only want my server to give out 1,000 features at a time. If there's more than 1,000 features, then just give out the first 1,000 features, and also make sure that the client knows that you didn't get a full feature set. So you'll know if you ever get in this situation where you've added too much, because what will happen is your map, like if you try to pan or zoom on your map, it'll just be really slow and unresponsive. So typically, if you have a very complex map, it might just be better to do it the traditional way, which is actually what we're going to talk about in the future in this class, making a dynamic map service. All right. One of the way that we could get around this is to generalize the layers that you're going to draw on the client. So if you're making a map of the United States, let's say you're making a map of all of the states in the United States, and you're planning on your viewers viewing your map at that scale, all of the United States, and you're not really planning on them zooming in, or if they're zooming in, you're planning on giving them a different feature set to deal with. One of those two scenarios, what you can do is generalize. And inside ArcGIS, I don't have ArcGIS open, but there's a whole toolbox that allows you to generalize data. It's called, pretty sure it's called the cart. Now I'm opening it twice. Yeah, here, I'll show what I mean by that. So here's the United States. Okay? Now, if I zoom way down in the United States, you can tell that this is already fairly generalized, right? I mean, that's not how the Louisiana coastline looks. It's more intricate than that by a lot, right? And so let's say that it looked, and that's our coastline. That's actually a pretty bad representation. This is Bay St. Louis, this is Biloxi Bay, right? And those also don't look like that. So this looks like there's only one point between the end of Bay St. Louis and the beginning of Biloxi Bay, which is a fairly bad generalization. So if I'm zoomed in at this level, this doesn't look very good. However, if I'm at this level, where I'm looking at the United States, in other words, if my web map was for people looking at this view, then I'm not concerned that Bay St. Louis and Biloxi Bay aren't drawn correctly. I've got some pretty good details still. I still got all the islands off the California coast. You can see I've got a San Francisco Bay polygon. I may even, depending on my application, I may even want to generalize this even further. So under cartography tools, there is a generalization thing where you can basically play with it. So you've got the simplified polygons tool, and you can go into that one, and there's a couple different algorithms. I don't know why I think it's because I changed the screen resolution on my screen that it doesn't look good, but let's do point remove and change the offset to 30. No, that's 30 degrees. How about 0.5? That's still a lot. 0.1. I'm going to run this, and we'll see what the difference between the two data sets are. Right. Exactly. See, now we've smoothed out the entire Mississippi coastline. We don't have anything left, any bays left. Well, we still have some of Biloxi. I mean, Bay St. Louis. We smoothed it out, and these are actually all of the points. I think. No, I don't know what those are. But these are the simplified polygons, and those are the original polygons. If this was an image, it would tell us how big this is on disk. Let's see if it says that. No, it doesn't say that here. And since this is in a geodatabase, I can't. Let's look here real quick. So I'm going to call this small dot shape, and I'll call this data, export data. I'll call this large dot shape, or larger. Then I'll look in here, and you can see that small dot shape is 42 kilobytes, and large dot shape is 179 kilobytes. So it's what, three or four times smaller in size. And when you're on the internet, that can matter. Especially here, 179 is probably already small enough. It's already generalized enough. 179 kilobytes comes over on most computers pretty quick. But let's say this was still an order 4 times magnitude. One was 1 megabyte versus 4 megabytes. Well, 4 megabytes is starting to get where there's some latency when it comes over. It might take a second or two for it to actually show up on the client. And of course, internet speeds are going to keep getting faster and faster, but there's always going to be latency, and so basically, internet speeds are going to get faster and faster, and people will be able to put more and more vector data. But there'll always be a point where vector data is not the way to go because it's a lot of data compared to just passing over an image. And there actually is a point in the other direction where if you only have 20 points, it becomes silly to not do vector data because it's so much smaller than it would be if you converted it into a raster image. So basically, one reason why you wouldn't do it is if you just had a whole lot of data. And then one way to overcome that is you might switch to loading a more detailed file when the user zooms in. You could just load the data from that area. So let's say you had 1 million points. So one solution would be to, instead of load all 1 million points, you just load all the United States and you symbolize the map by how many points are in every state. And then when they zoom in, you say, okay, well, you zoomed in far enough that I can ask for all of the points in this box, which might be 50,000 or so. And then I could symbolize those on a map pretty easily. All right, another drawback is that, I guess this is one of those where it's a balance. Labeling, in other words, putting labels on your map, can be a challenge with browser-drawn graphics. I'm not talking about symbolizing, I'm talking about actually putting a label on there. And one of the reasons why this is tough is that there's actually pretty complex algorithms that go into ArcGIS's label placement. And those label placement algorithms have not yet they've not yet made it into JavaScript programs like ArcGIS JavaScript API or Leaflet. They're not there yet. And so when you say to place a label, what it usually means is that you're just putting the word right above it. You could write your own little code to put it in a different place, but there if you go into GIS and you label features in GIS, it will decide, okay, well, if they're overlapping, don't put them. If they're if one is on top and then there's another on top and they're overlapping, move one to the bottom. If that's taken, move one to the left, move one to the right. There's all sorts of rules that go into creating labels, so it can be challenging. But one way to overcome that is to actually not place labels on your map, and instead have a good legend that helps users to see what the symbols mean, and for more information about a particular point or a particular location, rely on clicks, because that's something that you don't have on a paper map. So you have this problem where labeling is problematic, but you also have this opportunity where the user can actually interact with the map that you wouldn't have on a paper map. All right, and then finally, symbol choices right now are relatively elementary. The cartographic engine that's inside of ArcGIS, I don't know if maybe some of you have spent a lot of time looking at all the different fills. Like you can make a Mars symbol fill, and there's all sorts of different stroke sizes and shapes. Well, they're pretty elementary for web design. So you can basically fill with a different color. You can actually fill it with an image, but it doesn't always look as you would expect. And the lines are basically restricted to dashes, which can be big or small. And then you also have a whole array of symbol choices to choose from inside of most desktop applications like QGIS, ArcGIS. You can choose a highway sign or something like that. All right, how do we draw the vectors on the client? That's what we're going to practice today in today's examples. So we're going to use Leaflet, but there are different versions, different ways to do this in different web mapping APIs. And so basically they involve taking GeoJSON, we're going to use GeoJSON, or something like KML, and turning them into points, lines, and polygons that are then symbolized and put onto a layer. Okay? Just like in GIS, we're talking about layers. One of the things that's different about GeoJSON than your traditional ArcGIS layer is that you can mix data types in GeoJSON. So you can say, I want some polygons and some lines on the same layer, some points and some lines on the same layer. So we are going to focus on GeoJSON, and we're going to talk about getting our data. And we'll go into a little bit more of this next time we meet. So today we're going to talk about basically this first one in our examples, which are so we've got so far up to this point we've talked about getting vector data from the internet. Okay? And it's going to be points, lines, and polygons. How do we do that? Well, one way is just when the page loads to ask the server, and it may be the same server that the rest of our page came from. In other words, we may have our HTML file and then our data file located right next to each other, just like if we were trying to put an image on our page, we're trying to put data on our page. They might be right next to each other. So when the page loads, the main HTML code asks for the data right then and gets all of the data at that moment. And that's the simplest way to do it. That's the way we'll practice today. So retrieve all the data at the time the layer is loaded. So if there is a lot of data, this method does require an initial performance hit. In other words, you're loading all the data at once, and so if you have a bunch of data, it might take a little while for your page to load. But the nice thing about it is once it all loads and you have it in memory, you can do things. You can even do some simple GIS operations. Like you could say, okay, I want to see all the points in this polygon, things like that. And it never has to go back to the server to make a request for anything. So the only time this is not ideal is when you have a very large amount of data. So this is the ideal approach if you can get away with it. All right, so this is the second approach here, is to retrieve only the data within the current map view. And so what happens here is that every time the user pans or zooms, you make a new request. So you have to, what do we call that? What do we call what? When we have a function that is waiting for a user action, what do we call that type of function from last week? Last time we met. I haven't asked a lot of questions, so all of a sudden I sprung one on you. So. Now, there's maybe two correct answers. So the one starts with an E. An E. What? No. That's good though. So like we did it last week when we had a function that ran when the user clicked, right? That function is waiting for an event. That function's waiting for an event. So you could have a function or an event handler that's waiting for a pan or a zoom on the map. And then when the user pans or zooms on the map, you could reload the data. You could ask again, okay, here is the polygon that represents my current view, the boundary. And I could say, okay, server, hand me all of the data inside this current view. Now that does require that your server is set up to handle that kind of request. Okay? So we won't actually do this until we talk about servers, which is what we're going to start doing after the test. So that's a topic down the road. But you could see if you had a lot of data, how that might be more advantageous. You're not loading everything all in at the same time. Only when the user needs to see that data does the user get that data. All right, and then the final one is to retrieve only some of the vector features from the data set based on a filter or query condition. And we can do this today because this is basically just paring down the data based on a need to only see some of the data. In other words, I don't want all of the data. I don't want all million points. I'm only interested in fire stations, or I'm only interested in these type of events. And there's actually two different sub categories of this. One is that you might be forced to download the entire data set, but you won't be forced to actually put all those features on your map. So depending on whether or not the server can handle a request to say, I only want to see, let's say we're dealing with states. I only want to see those states in the southeast. Well, the server may not be able to handle that request. You may just be able to say, show me the states layer. So it passes all that data over as a GeoJSON file. You could then weed out just the states that are in the southeast. And that would be a way to make it so that your map might be a little bit more responsive because it didn't have so many points. However, you would still have to download it all, so the initial loading of the data wouldn't be any faster. So ideally, it has the ability to handle that request, and you can say, okay, I only want to see the states in the southeast, or the states that have fit a certain criteria. And I'm not saying that these are all describe completely the different strategies, but most of them fit into one of these categories. I already gave it an example of modification of this one. But you could have slight variations of the other ones. You can even mix them. Like you could have a very coarse data set loaded for the entire area, but then once people zoom in, you could switch over to this approach. Things like that. All right. So let's get into the GeoJSON itself. What is it? What does it look like? I've already mentioned that the JSON stands for JavaScript Object Notation, and it's bigger than GIS by a long shot. This is currently how almost all the data is transferred around the web is through JSON formatted data. GeoJSON is a specific way to transfer, and there is a specific format that's used in GeoJSON, specific way to transfer points, lines, and polygons. But other than that, it's just like JSON. It just has geometry fields that have specific names. Okay, the geometry fields have to have specific names. So GeoJSON is less bulky than older XML structures such as KML. KML, though, does have the ability to store styling information, which GeoJSON doesn't. Okay? GeoJSON, you'd have to find another way to store the styles. So you could think of GeoJSON more like a shapefile, and KML more like a layer package if you were talking about ArcGIS, where it's storing the data and the styling together. All right. So GeoJSON is a very simple package. I mean, a very simple format. It kind of looks a little bit weird here. But let's talk about it. Okay, so this data here is a feature collection of the state of Montana. And it's bigger than this page. This is just a snippet of a feature. Well, actually, I think this might be the whole thing, but it's a simplified version of Montana. Okay. So we've got a feature collection, and a feature collection can have points, lines, or polygons. A feature is an element inside of a feature collection. And a feature is usually thought of as a single entity. It doesn't have to be, but typically that's what we think of as a single row in an attribute table. So what I'm talking about here, if we go back into GIS and we look at this, look at the attribute table, a feature would be a single row, like this is one feature. In fact, the feature that is Wyoming is on here somewhere. Oh no, it's Montana. So there's Montana. Everybody know where Montana is? Okay, so there's Montana, and this is the feature Montana. And so in this GeoJSON file, there is only one feature collection. Typically, that's the case. There's also only one feature. Now, that's not typical. Typically, you'd have more than one single feature. Okay? Now, the feature here starts right here, and it has attributes. One of its attributes is ID. One of its attributes is properties. One of its attributes is geometry. Okay? In fact, those are the only attributes it has. Now, if you look at this format in JavaScript, what does a squiggly bracket mean? What data type is that? What's that? It's the starting of a function. That's true. But in this case, like if it's the opening of an object. Okay, and then what does a square bracket mean? JavaScript calls it an array, but last week I said we could just go ahead and call it a list. Remember? So what this is saying is that this is an object, and this object is going to be a feature collection. And that's why there's only one, because usually you'd think of a feature collection as being a group, and there's one feature collection. So that's why it's starting the squiggly bracket and saying feature collection. Now inside, we're going to get the features, and we're going to get a list of the features, and that's why we had this bracket. Okay? Let me try something real quick. It might make it a little bit easier to read. Control C. This is a website I use sometimes. Well, this might not work because. Yep. Okay, it worked. So this website is called jasonlint.com. You could paste JSON into this text file, into this text editor, and it does two things. One, it validates it to make sure that it can be read by JavaScript. The other thing that it does is that it beautifies it or makes it pretty. And I don't mean that it makes it look like strikingly beautiful or anything, but it makes it a little bit more easy to read. So you can see, because it places everything on the same level. That is the same level. So we start out here, and we have an object, and these are everything on the object level. So these are all attributes of the object, the type and the features. There's no other attributes of the overall object. There's just type and features. It's a feature collection, and these are the features. So now when we go into here, at this level, the two tabs in, these are all attributes of the first feature. So type, ID, properties, geometry, everything that's on this line. And then here, these are all attributes. These are attributes of properties. So FIPS and name. And these are attributes of the geometry, polygon and coordinates. Now, you'll rarely create your own GeoJSON. Okay? There are tools out there, and we'll talk about these. In fact, one of them is ArcGIS Server. So we'll install our ArcGIS Server, and it will create these files for you. You can send it a request, and it will do that. Sometimes they're already out there on the internet. I should have gotten the URL for this one. I meant to do this before, but earthquakes. I always use this example because it's a good one. USGS. Should have gotten the URL. Real-time GeoJSON feeds. Okay. So, yeah. Here we go. If I click on the magnitude 1.0 plus earthquakes, here are the magnitude 1.0 earthquakes that happened within the last hour. And this is a GeoJSON feed. See that? And so I'm going to copy this into JSONlint real quick because I want to see it more pretty. That doesn't sound right. My mom would probably get upset if I said that. So I want to see a prettier version of that. So now we can see that this one also contains a single feature collection. This one contains an additional attribute called metadata, which is just data about data. But when we get down into here, we've got features. So what do you suppose, how many features do you suppose we'll see? You know, one, or do you think we'll see multiple features? Multiple features, because there's probably been more than one magnitude 1 earthquake or greater within the last hour. Maybe, I guess. So we see that there is, this is the start of that. We see that there's one feature right here. I scroll down. There's only been one. So I think this this thing does allow us to do. I don't know if this is the URL. I'm just going to try it. Yeah. Okay. So I just changed that to all the magnitude 1 earthquakes within the last day. Control V, validate JSON. Now we have all of the same information, but within the last day. See that we still have the same one as the first one. Okay, but if we scroll down here, you'll notice that we have a second feature. This one happened 4 kilometers south-southeast of Paris, California. This one happened 31 kilometers west of North Nanina, Alaska. We can scroll down. Every time we see this, we're starting a new object. Okay, that's the ending, the old object. This is the comma between them. This is the start of the second object. So go down here. There's another one. 6 kilometers south-southeast of Bombay Beach, California. And so on. Get a lot of California ones there. There's one in Washington. Okay, but all of this other information is the attributes. Now, we're going to use this information inside of Leaflet. It's not really that important that you understand exactly how to read this, other than you should be able to, not for the test, I'm just saying, you should be able to tell what the attributes are for each of these data, because you can see this is a feature, these are the properties or the attributes of that data. I wonder what happens if we go to this URL. This URL is one of the attributes of this particular earthquake. So it looks like this is a report on this earthquake, where it happened, other earthquakes in the area. It looks like nobody felt this earthquake. Nobody's responded that said that they felt it, which makes sense because it was 12 kilometers deep and it was a magnitude 1.5. People in California probably thought that their kid walked across the floor. That's a small earthquake, especially in an area where people are used to feeling earthquakes. Okay. So that's GeoJSON. That's the format that it's in, and that we can get it in a few different ways. So this example that I said I uploaded, I haven't quite uploaded it yet, but we'll do that right now. Okay, I'll upload that, and we'll look at that. So here is the example that I'm going to upload. So we've got this file called data. And this is some GeoJSON. And this is the GeoJSON for Montana. I've also added this other one, this other feature inside of that. So there are 2 features. We've got Montana, and we've got another feature that I just named Jim. I don't know why I named it Jim. I don't even know if I have any friends named Jim, but I did, just to show you an example of how it's created. So I'm going to go ahead and upload this, and we're going to play around with that data on the. We'll use the data set that we've currently played with. I should have uploaded this before class, but the internet wasn't great in Dallas, which is where I flew. Whoops. Okay, why don't we take our break right now? I'll upload this, and I know it's like a half hour earlier than we usually take our break, but that way you don't have to sit here and watch me upload it. And it'll be all ready when you get back. I'm going to stop the recording for a second, and I'll start the second recording.